Alright, so in this video we're looking at Chapter 3.5, Graphing Linear Equations in Three Variables. Now, solutions of equations in three variables can be pictured using a three-dimensional coordinate system. To construct such a system, begin with the YZ coordinate plane in a vertical position. Now, sometimes people tell you X and Y, but because you're already used to drawing a horizontal and vertical, then it's easier to draw the YZ vertical position. Now, in a three-dimensional graph, the Z-axis represents the vertical. The y-axis is the horizontal. So if you start drawing this off on graph paper, it'll be easier. Now the next thing to do is to draw the x-axis as a diagonal line through the origin. It's easier to draw, in essence, the xy line, as it looks very similar to that. So if we draw that, we see we get the x-axis. And if you look at this carefully, you can see a three-dimensional figure, sort of like what you'll look at the corner of the wall. If this was a corner of a wall, the z-axis will represent the corner of the wall that is vertical. The x-axis will represent the wall that comes on the side of the wall, and the y would be the other side. And so you can see you could put something within the corner of that wall. Now that you have drawn that part, what you can also do is add in the other axes in using dashed lines. Using the dashed lines gives the illusion that it continues going on without actually drawing a line in that can make it a little bit more confusing. Alright, so like the two-dimensional coordinate grid that has ordered pairs, the three-dimensional grid has ordered triples. And so you have x, y, and z that you can graph. Now, when you graph these things, they represent a plane in space. So just picture if your ball was floating, you had a tennis ball or basketball that was floating in your room, then you can actually put that onto a 3D coordinate grid and map that as a coordinate or ordered triple. So instead of having four coordinates in all, the three-dimensional grid has 8 octants, where each plane is taken two at a time. So you see here we have the YZ plane. Now the YZ plane can also be on the other side, the left side of that, where it would traditionally be the other side of the XY plane on a two-dimensional grid. So we're just going to look at the positive sides. So the YZ positive plane, the XZ positive plane, and the XY positive plane. Alright, so if we do that, we see we also have the XZ positive plane, and if you look down, there'll be one underneath it as well. Then we have the XY plane. Now we can also have a two, because there are three there, we can have another two additional, which makes the 8 in all. But we just really need to concentrate on those three. If I was to look at those three, basically, I can now have a basic understanding of what a three-dimensional grid looks like. Now what we want to do is practice graphing these. So if I wanted to plot an ordered triple in a three-dimensional coordinate system, we would do so by first finding where the x coordinate is. The x goes first, where the x point would be on the x-axis, and then on the y-axis, and then the z. And just say the similarity with these two-dimensional grid, we look to see where they meet. We do the same thing here. Now it could be a little bit tricky, so pay attention and make sure you practice, as practice makes progress. So let's first look where -4 would be on the x-axis. Notice that the x-axis is the one that is going diagonal in, if we were to look at it as a two-dimensional grid. And so we see here the x-axis. If we go past 0, on the dashed line, we see that -4 would be the fourth notch. If we do the same thing for the y-axis, we see +2 would be where traditionally the x-axis would be on a two-dimensional grid. But because now that's the y-axis for three-dimensional, we see where that would go, 2 notches from the origin. And then lastly, the z-axis, which represents the vertical, would be 5 units up. Now that we know where those values are on each of these axes, what we want to do is match them up. So if we start with that -4 and the 2, just like we would with any other graph, we can match them up to there. But this is where it can be a little bit tricky for students, is bringing in the vertical. Now because the vertical line is now a distance away, think of it in real life. As a car drives off in a 3D world, the world we live in, what happens is it looks smaller. Well, we have to keep in mind that this is what's happening when we graph. So we don't want to just mark where 5 is. we actually need to measure 5 units as if it were on the intersection of the -4 and the 2. So what do I mean? Well, first we want to get an idea of how long 5 units is. So what we can do is we can use a ruler and just make sure that we know where our 5 units on the graph matches to 5 units on the ruler. Once we get that little marker there, we can mark it on our ruler. We could just bring that over figuratively. So imagine this graphic. We're moving it over. Now notice that purple line is no longer just at a glance the same 5 units. Most people would actually try to draw the 5 units as follows. They'll just try to put the point there. But as you see, that's not 5 units. That's actually something really smaller. And that's possibly 2.5 units or even 3 or even 2 units itself. And so what we have to do is make sure that where that line matches is actually 5 units because we're thinking three-dimensionally. So once we do that, once we go and drag that point over, that dimension over, we can see that the point would be at the very top of that. And that's where a point would be, -4, 2, 5. All right, so let's do part B. Remember, you have to draw these axes out. Remember, draw the ZY axis first, then do a diagonal x-axis. It's basically the y equals x line. It's easier to make sure that your positive axes are solid, and then the negative axes are going to be dashed lines. That makes it stand out a little bit easier. All right, remember to do this, we're going to first find the value of x, which is 2. And so on the x-axis, we mark where 2 is. Then on the y-axis, that's -5. And so on the y-axis, we go to -5. And then the z-axis, our vertical, is going to be -3. And so when we see where the x and y meet, that's what you always want to do first. It's easier to find where the x and y meet, and then use your understanding of the dimension of the vertical to map your way down. So we see where they meet there. We want to get the vertical distance of our z-axis, -3 units from the origin, and then we want to translate that over to where the x and y meet. Once we do that, we can see exactly where all 3 points are really meeting, and that's at the bottom of the purple line. All right, so remember the steps to do this. First, draw your y and z axes, your positive y and z axes, then do a diagonal line, which is basically like drawing the x equals y on a two-dimensional grid. That would represent your x-axis. Keep those solid to represent your positive axes, and then from there extend the lines using dashed lines to represent the negative axes. When you plot your points, make sure you choose each value, x, y, z, see where the y and the x points meet up, and then simply translate the distance, the vertical distance, between your origin and the value on z over to the intersection of your x and y values. Once you do that, just put your point at the top or bottom of where the z-axis or the z value ends. All right, let's do a little practice to see if we understand visually how a three-dimensional graph works. So this is taken from page 173 in the textbook number 6. And it says, write the coordinates of the vertices A, B, C, and D of the rectangular prism shown, given that one vertex is the point 2, 3, 4. All right, so let's start off with A, and we want to see what the point A would be. I'll just write the values on the side. So we're going to find out what A is going to be, what B is, what C, and what the value of D is. All right, so this tests your ability to think three-dimensionally. And let's start off with what we know. If we look at what we know, we see this point here that's given, right? 2, 3, 4. And we're going to use that just like we would any other point to figure out what the other values that have been indicated are. All right, to do that, we see that this point, which is given, and the point C are in line in the vertical distance, right? But then we see that the point C also lines up with the y-axis, right? So we want to get all 3 dimensions to get an idea. So it matches up with the z-axis, it matches up with the y-axis, and then also what we want to see is where does it lie in terms of the x-axis. And if you see on the x-axis, it's lining up in terms of the 0. And so from there, we can determine our points. So starting with the point C, we see that on the x-axis, that is on 0. Then if we go to the y-axis, 3. Alright, then last of all, we see that this point C, or the point C, is actually in line with D, which on the z-axis, our vertical axis, is 4 units high. And so that would be the coordinate point for C. 0, 3, 4. Alright, so we're going to do the same things for the other ones. And so let's start off with maybe just go over to D. So if you look at D, notice D is in line in terms of the z-axis with C. We see that it's right above the origin. And so on the x-axis, it's at 0. So we see at the x-axis, D is at 0. On the y-axis, we see that's also at 0. And then lastly, if we look at the z-axis, the actual vertical, we see that it's the same as the C and the D point, or the original point. So we have 0, 0, 4 for point D. All right, let's go ahead and look at the next one that's on the top, which is A. Sometimes it's easier just to begin there. We know that everything on the top is going to have a z value of 4 since they're all at the 4th level. It's 4 units up to the very top of that box. So if we go with A, first we want to look at the x value of A, and we see that A is right above on the x-axis the point 2, or the value 2. So 1, 2 units from the origin on the x-axis. So we know our point A is going to start at the value 2. Then we look at the y value. Now you notice on the y value, which would have been here on this line, the y values there are zeros. So that means that our value at that point is 0. And then lastly, because it's on the same plane as the very top of the box, we know that the z value will also be 4. Alright, so we knocked off the top points, and now we go down to the bottom. They only want 1 from this diagram, and that's the point B. Now if you look carefully, the point B, we can be assisted there simply because I'm just looking for a color to use, and let's just use orange. If we look at point B, is right below the original point. So that means it's going to be almost identical except for one thing. The vertical point is going to drop down to 0. So basically we're going to have 2, 3, and then instead of 4, 0. And that's how you find all your points. And so we have figured out our points by utilizing our spatial recognition.